Every day, billions of people interact with artificial intelligence without ever thinking about what makes it possible. You ask a question, and you get an answer. You upload a photo, and it's tagged and organized in seconds. It feels like magic. But behind the curtain, a vast, invisible machine is working around the clock. The infrastructure that powers intelligence itself. This is the story of the hidden systems driving the AI revolution, from the supercomputers that think to the engineers who keep them alive. AI doesn't live in the cloud, it lives in buildings. Massive data centers spread across the globe, connected by fiber networks faster than the blink of an eye. Each mode, ChatGPT, Gemini, Midjourney, runs on rows of GPUs, humming in sync like an orchestra of processors. These GPUs aren't like the gaming card in your PC. They're specialized, designed to perform trillions of complex calculations every second. And they need a staggering amount of power. A single large language model can consume as much energy as 1,000 homes. Cooling systems, liquid nitrogen loops, and redundant power grids are all essential to keep them alive. AI may seem digital, but its heartbeat is undeniably physical. If computation is the body of AI, then data is its lifeblood. Every AI system feeds on information, structured and unstructured, clean and chaotic. But raw data isn't useful on its own. It has to be processed, cleaned, normalized, and labeled before a model ever sees it. This is where AI pipelines come in. These are automated systems that collect data from millions of sources, filter out duplicates, attempt to remove bias, and convert human knowledge into machine-readable formats called vectors. From social media text to public domain books, from code repositories to satellite imagery, everything is refined, organized, and fed into training clusters. The training process isn't glamorous. It's slow, expensive, and endless. But it's the foundation of every breakthrough you see today. When you ask an AI a question, it doesn't search for keywords like Google does. Instead, it thinks in vectors, mathematical fingerprints of meaning. A vector database is where those fingerprints are stored. Each piece of text, every image or sound, is converted into a numerical pattern. The AI then retrieves information that is similar in concept, not just in spelling. This is how modern models achieve semantic understanding. The difference between simply finding the word dog and knowing it's related to pet, bark, or walk. These databases are redefining search and knowledge retrieval. They make reasoning possible, context-rich, and memory persistent. Without them, your chatbot would forget everything it learned just 5 minutes ago. Training a model is one thing. Deploying it at a massive scale is another challenge entirely. This is where MLOps machine learning operations takes over. It's the discipline of managing AI systems from research all the way to production, ensuring reliability, version control, and continuous learning. Every model you interact with is constantly being retrained, refined, and patched. Engineers monitor for drift, which is when a model's behavior starts to deviate from reality. And they push new updates daily. The result is an ever-learning organism, part code, part human coordination. Behind the AI boom is a global race for hardware, data, and energy. NVIDIA currently dominates GPU production. Cloud providers like Amazon, Microsoft, and Google rent out compute power by the second. New data centers are rising in places like Iceland, Norway, and Canada to take advantage of cheap, renewable energy. But this supply chain is fragile. Semiconductor shortages, geopolitical tensions, and ever-increasing energy demands threaten to slow progress. AI's power isn't limitless. It's borrowed from the grid, from human labor, and from rare minerals mined around the world. Every digital miracle has a physical cost. And yet, the infrastructure of AI is evolving. We're seeing systems that can design new chips, optimize their own cooling, and even write code to improve their training pipelines. We're entering an age of recursive automation, where the machine improves the machine. Autonomous agents are starting to handle model tuning. AI compilers are rewriting algorithms in real time for better performance. Even the cloud itself is becoming intelligent, predicting demand, balancing loads, and scaling resources preemptively. Tomorrow's breakthroughs won't come from a single company, but from the invisible collaboration of thousands of machines, thinking together across the planet. Artificial intelligence isn't just algorithms, it's architecture. It's the silent infrastructure shaping the digital age, built by unseen hands, powered by unseen systems, and evolving faster than we can comprehend. Behind every prompt, every pixel, and every prediction lies the hidden network that makes intelligence possible. The real question is, how long can we keep up with what we've created? Thank you for watching. If you found this look behind the curtain interesting, please consider liking this video and subscribing for more deep dives into the technology that's shaping our world.